Okay, this is 2024 ASL Thompson 2 paper 2 question 6, which is also SL. SL question 5. I guess this question deserves its own video. So you're given a binomial distribution where the unknown is actually the number of trials, and you're supposed to find n so that the probability that the number of successes is bigger than or equal to 1 is bigger than 0.99. So I know a lot of students in that year simply do trial and error on their GDC to get n, and that is actually accepted, right? That's actually a method that is in the marking scheme. But I guess I'll show you the actual intended way. The intended way is this. The intended way is to realize that the probability of x bigger than or equal to 1 is the same as 1 minus the probability that x is 0. Right? Because x being 0 is the opposite of x being bigger than or equal to 1. So if you use the total probability of 1 and take away the probability that x is 0, then you get the probability that x is not 0, which means x is bigger than or equal to 1. Okay. But then we can subtract the 1. So this is bigger than 0.01, which means, negative. The probability of x equal to 0 should be less than 0.01 because you're dividing both sides by a negative. In an inequality, if you divide both sides by a negative, you need to flip the inequality side. Okay. Now then, this is where the binomial thing comes in. So what is this saying? This is saying that you have no success, right? So after n trials, you have no success. If you think about it, how can that happen? Well, it means in all of your trials, you get failures. Now, the probability of success is 0.25. So the probability that you get one failure should be 0.75, right? 1 minus that. But in all n trials, you need to have like all fail, right? So all n trials are fail. So the probability for that to happen would be 0.75 to the power of n, right? Because it's like the first trial is a fail, and then the next trial is a fail, and then the next trial is a fail, so on and so forth, and then you multiply them out, and then you do n times, right? So it's 0.75 to the power of n. So you really want 0.75 to the power of n to be less than 0.01. Well, this is something you can solve by graphing. Right. So if you do it this way, you don't even need to touch binomial. And then I want them to intersect, and it's an intersection, I think it's here. It's 16 something, so n is 16 something. So when n is 16 point something, they would equal, right? Intersection means they would equal. But I don't want them to equal. I want the blue function, the blue curve, to be even lower than 0.01. Right, and this is 16 point something. So if I want it to be lower, I'll need 17, right? Because this number of trials, it can only be integers, so n is 17. So this is the intended way. What about the trial and error way? That's actually possible. What you do is you go to where you calculate binomial. Where do I calculate binomial? Here. And then you put random number for number of trials. The success probability is 0.25. And then you find the probability that x is bigger than 1. And then So here I tried n being 20, so that kind of work because it is bigger than 0.99. I got 0.9968, but I need the smallest n that can do this, right? So that means now I know 20 works. So I need to change 20 to 19 and do it again. Oh, that's still bigger than 99. So you keep trying until, well, now I know the answer. So until 17. Okay, you're supposed to write down the probability. The probability that x is bigger than or equal to 1 is 0.992. But then you try the next number. Oh, it's less than 0.99. Therefore, the answer is 17. All right. So if you do this, they will also give you full mark, which is what? 5 marks.